summary output that we get. I'm going to resize the columns in the worksheet by clicking in the grey box to the left of A and then double clicking between A and B. In our output we have an adjusted R squared. I'm just going to embolden that. What this tells us is that almost 98% of the variation in the Y value, that is in heart rate, was down to the increases in the work rate. So R squared is the proportion of the total variability that can be accounted for due to your X variable changing. You'll also see that we have an analysis of variance table. So we have a component of the total variability in the data which is due to regression, and a component which is due to residual, that is the error. The only important thing that you need to know about here is the significance level. Again, I'm going to embolden this. So we have a very, very low significance there. This is 6.5 times 10 to the minus 9, or 0.0000000065 for a significance level. One other thing that we have in the graph on the chart here are coefficients. So we can express a relationship between heart rate and work rate by an intercept. So the resting heart rate, the place where we had no work rate at all, was 75 beats per minute, and the work rate then was 0.4138. So we started off with a resting heart rate of 75, and then for every 1 watt increase in the work rate we got an increase in the heart rate of 0.4 beats per minute. This is very useful. Finally, we have two graphs. Get rid of the predicted heart rate by clicking in the box and then on predicted heart rate and hitting delete. This will tidy the graph up a little bit. And then we'll resize the graph a little bit. Click on heart rate and get rid of that. Let's just square the thing up. You should be able to see that as work rate increases, heart rate increases as well. So the graph represents the relationship between heart rate and work rate very well. Let's just tidy these up by putting on a descriptive label on them. So if I click on work rate and then click on the end, I can physically type in work rate watts, and simply here click on heart rate, click again. I'm going to click and drag. I'm going to type in heart rate, open brackets, beats per minute, and then click anywhere on the graph to tidy it up. Finally, we want to rescale these. It doesn't really make much sense to actually have the thing starting at 0 when the resting heart rate was 75, so I'm going to double click on the axis, go to scale, and start it on, say, 70 beats per minute, up to 190 every 20 beats. Okay, so the graph is reasonably well laid out now. You should be able to see though that you've got one aberrant point here. I don't know what happened here. Maybe the heart rate monitor clip moved and you got an erroneous value. You can also see that as work rate increases, we're getting a steady increase in the heart rate up to about 180 beats per minute, and then the thing seems to be leveling off. So these last 2 points here don't fit in with a nice straight relationship here. Finally, let's have a look at the residuals plot. The residuals plot is the deviations from the line of best fit in the Y direction. And you can see that it's tending to be frowning at us. The reason for this is that these last two values tend to be going down against the trend. So looking at the residuals plot, if you have a good straight line fit to our data, we'd expect just a cloud of residuals about this straight line here, with no apparent trend to it. If the residuals are frowning at us like they are here, or if they're smiling at us, or if we have some kind of S-shaped curve to the data, then this all indicates that it's not a good straight line fit and you have to do something with the data.